Okay, context is steaks. That's right, yeah. So a restaurant is serving steaks, and they're trying to serve 82 grams per serve, and there's a standard deviation of 5 grams. Okay, and they have a little chart that says all the steaks less than 70 grams is going to cost $1.40, and then you have all these different intervals. Okay. So part A says we're going to find the probability that a steak is between 80 and 90 grams, chosen randomly. All right. So let's convert these into z-scores first. 80 take away mu, which is 82, divided by the standard deviation, which is 5, comes to, type it in. Negative 0.4, good. Good, still do fast. And let's let's find the probability that z is less than negative 0.4. Okay, we need our little diagram. Here is negative 0.4. Okay, and we're going to use the symmetry and say that this area is the same as this area, 0.4, subtract that area. So it's going to be 1 minus the probability that z is less than the positive 0.4. Okay, so look up the table for 0.4.
0.6554.
Yes, I agree, Errol. 0.6554.
Yeah.
Good. And 1 subtract that is 0.3446. Good. Okay. Let's find the z value now for when x is 90. 90 take away 82. Divide that by 5. Comes to 1.6.
Yeah.
Okay, so here's a little diagram. 1.6 is here, and we want to be. Oh, I think I've got these backwards, don't I?
Yeah, you did.
Yep. Thanks for pointing that out.
No, I just noticed it, just that you noticed.
Yep. So we need less than 90. So we want that area, not this area. So I don't need to manipulate the tables, I don't need to manipulate that, that's fine. I want this region, so 1.6 in our table says
9.9452.
that's right, yeah. So this is the probability that z is less than 1.6 is equal to 0.9452?
Yeah.
9452. Okay, excellent. So that means that the region in between 80 and 90 is going to be one, subtract that area and subtract that. Ooh, hang on 1 second. It's going to be all of this, but subtract that area. Yeah? Oh, I better see that again. Take that 90, that 0.9452, which is all of that, subtract the 80, which is 3.446, so subtract that, and we'll get the middle region. Okay, so let's finish this question. The probability that x is greater than 80 but less than 90 is equal to 0.9452 subtract 0.3446. And what does that come to?
0.6006.
0.6006, yes. Very good. So that's the probability for paying a $2 steak. Alright. Cheap steaks, eh?
So you can go
Well,
away.
but they're really tiny though.
Oh, sorry, yes, $1.80 steak. Yeah.
So they're really tiny steaks.
Yeah. I
Actually,
don't know about
very
these prices.
80 to 90 grams.
Mm.
Is that
It's a
Okay.
steak.
That's not
It's a tiny
It's a
little
steak.
That's a ham leg.
It's a bench.
Ben, that's your ham. It's a wrap. That's
Uh,
your leg, bro.
It's the average steak that you buy is like 250 grams. So.
Okay, let's do part B. We're going to find the probability that a steak costs $2. Well, $2 is here, so it's really asking us to find the probability that x is greater than 90. Yeah? And so let's try and do this one really quickly. Z is equal to 90 take away 82, divide that by 5. What's our Z score? 1.6, good. And so we want the greater than, the probability that Z is greater than 1.6.
What is it the same as that? 0.9452.
Very good, Errol. We've already solved it over here, haven't we? Yeah. So we know that from our diagram, this here, 1.6, has 0.9452 is this side, and we want this side. Okay, so we're going to subtract it from 1, right? Which comes to 0.0548. Okay, so that's part B. Then they want us to complete this table.
It's the barrel after that.
And we've already solved these two. So at $2, we found that it was 0.0548. For the $1.80 steaks, it was over here, 0.606. Okay. We could spend the next few minutes working these out, but it's pretty much the same working out, isn't it? I'm going to give that to you just for now. 0.0082 and 0.3364. Okay, so that's completing the table. Part D says, find the average price of steak. We need to find the average price. Give me another word for average when it comes to statistics. Mean, right? It's the mean price. Okay. Another word for mean is the expected. The expected price. Now, last year, I'm sure you would have done this with Mr. Dobbins, so it's a bit of a recap from last year. The expected looks like this. Okay, and that's average, okay, or mean. And how do we find the average when it comes to this chart of prices and probability? Well, multiply those two, add to the multiplier of those two, add to the product of those two, add to the product of those two.
And then divide by 4.
Yep. That's it. So, this is going to be 1.4 times 0.0082. Start typing this in for me. Plus 1.6 times by 0.3364. Plus 1.8 times 6.006. Plus 2 times 0.0548. and it gives you a decimal 1.7404. Okay, so it's basically the average of all those prices at all those probabilities, and basically the average price is $1.74. Okay, so that's the expected